Rational knowledge and rational activities certainly constitute the major part of scientific research, but they are not all there is to it. The rational part of research would, in fact, be useless if it were not complemented by the intuition that gives scientists new insights and makes them creative. These insights tend to come suddenly and, characteristically, not when sitting at a desk working out the equations. They come when relaxing, in the bath, during a walk in the woods, on the beach, etc. During these periods of relaxation, after concentrated intellectual activity, the intuitive mind seems to take over and can produce the sudden clarifying insights which give so much joy and delight to scientific research. However, intuitive insights are of no use to physics unless they can be formulated in a consistent mathematical framework, supplemented by an interpretation in plain language. Abstraction is a crucial feature of this framework. It consists of a system of concepts and symbols which constitute a map of reality. This map represents only some features of reality. We do not know exactly which these are, since we started compiling our map gradually and without critical analysis in our childhood. The words of our language are thus not clearly defined. They have several meanings, many of which pass only vaguely through our mind and remain largely in our subconscious when we hear a word. The inaccuracy and ambiguity of our language is essential for poets, who work largely with its subconscious layers and associations. On the other hand, science aims for clear definitions and unambiguous connections, and therefore it abstracts language further by limiting the meaning of its words and by standardizing its structure in accordance with the rules of logic. The ultimate abstraction takes place in mathematics, where words are replaced by symbols, and where the operations of connecting the symbols are rigorously defined. In this way, scientists can condense information into one equation, that is, into one single line of symbols, for which they would need several pages of ordinary writing. The scientific method of abstraction is very efficient and powerful, but we have to pay a price for it. As we define our system of concepts more precisely, as we streamline it and make the connections more and more rigorous, it becomes increasingly detached from the real world. Again, using Korzybski's analogy of the map and the territory, we could say that ordinary language is a map which, due to its intrinsic inaccuracy, has a certain flexibility so that it can follow the curved shape of the territory to some degree. As we make it more rigorous, this flexibility gradually disappears. With the language of mathematics, we have reached a point where the links with reality are so tenuous that the relation of the symbols to our sensory experience is no longer evident. This is why we have to supplement our mathematical models and theories with verbal interpretations, again using concepts which can be understood intuitively, but which are slightly ambiguous and inaccurate. If there is an intuitive element in science, there is also a rational element in Eastern mysticism. However, the degree to which reason and logic are emphasized varies enormously from one school to the other. For example, the Hindu Vedanta or the Buddhist Madhyamika are highly intellectual schools, whereas Taoists have always had a deep mistrust of reason and logic. Zen, which grew out of Buddhism but was strongly influenced by Taoism, prides itself on being without words, without explanations, without instructions, without knowledge. It concentrates almost entirely on the experience of enlightenment and is only marginally interested in interpreting this experience. A well-known Zen phrase says, "The instant you speak about a thing, you miss the mark." Although other schools of Eastern mysticism are less extreme, the direct mystical experience is at the core of all of them. Even those mystics who are engaged in the most sophisticated argumentation never see the intellect as their source of knowledge, but use it merely to analyze and interpret their personal mystical experience. The firm basis of knowledge on experience in Eastern mysticism suggests a parallel to the firm basis of scientific knowledge on experiment. This parallel is further enforced by the nature of the mystical experience. It is described in the Eastern traditions as a direct insight which lies outside the realm of the intellect and is obtained by watching rather than thinking, by looking inside oneself, by observation. In Taoism, this notion of observation is embodied in the name for Taoist temples, Kuan, which originally meant to look. Taoists thus regarded their temples as places of observation. In Chan Buddhism, the Chinese version of Zen, enlightenment is often referred to as the vision of the Tao, and seeing is regarded as the basis of knowing in all Buddhist schools. A word of caution should perhaps be added here. The emphasis on seeing in mystical traditions should not be taken too literally. It has to be understood in a metaphorical sense, since the mystical experience of reality is an essentially non-sensory experience. When the Eastern mystics talk about seeing, they refer to a mode of perception which may include visual perception, but which always and essentially transcends it to become a non-sensory experience of reality. The parallel between scientific experiments and mystical experiences may seem surprising in view of the very different nature of these acts of observation. Physicists perform experiments involving an elaborate teamwork and a highly sophisticated technology, whereas mystics obtain their knowledge purely through introspection, without any machinery, in the privacy of meditation. Furthermore, scientific experiments seem to be repeatable any time and by anybody, whereas mystical experiences seem to be reserved for a few individuals at special occasions. A closer examination shows, however, that the differences between the two kinds of observation lie only in their approach and not in their reliability or complexity. Anybody who wants to repeat an experiment in modern subatomic physics has to undergo many years of training. Only then will he or she be able to ask nature a specific question through an experiment and to understand the answer. Similarly, a deep mystical experience generally requires many years of training under an experienced master, and, as in the scientific training, the dedicated time does not alone guarantee success. If the student is successful, however, he or she will be able to repeat the experiment. In fact, the repeatability of the experience is essential to every mystical training and is the very aim of the mystic's spiritual instruction. A mystical experience, therefore, is not any more unique than a modern experiment in physics. On the other hand, it is not less sophisticated either, although its sophistication is of a very different kind. The complexity and efficiency of the physicist's technical apparatus is matched, if not surpassed, by that of the mystic's consciousness, both physical and spiritual, in deep meditation. The scientists and the mystics, then, have developed highly sophisticated methods of observing nature which are inaccessible to the layperson. A page from a journal of modern experimental physics will be as mysterious to the uninitiated as a Tibetan mandala. Both are records of inquiries into the nature of the universe.